Hello, this is Rakesh Rao from Design Sense Software Technologies, Bangalore. In this GeoTools video, I'm going to show you how you can do some drawing cleanup. So mainly, we are going to see how we can snap nodes and lines to each other. So in GeoTools, there is a section called Drawing Cleanup, and in this Drawing Cleanup, there is a command here called Linear and Node Snap. It can be called on the command line by typing GT_NODELINESNAP. Now you can get it from the ribbon as well. So if you go to drawing cleanup, and over here you can see linear and node snap. Now you need to understand how this command works. So the first parameter is the snap type. So under snap type we have four types. We have a line to line snap, or a line to node snap, node to line, and node to node. Now node means point, and line you already know what it is. When you are working with lines or polylines, you can specify whether you want only the first and last vertices to be snapped, or you want all the vertices to be snapped. So that option can be specified here. In addition, the next option here specifies how you handle the Z coordinate. You can do the snap only in XY or in XY and Z also. This is a great tool because it helps you then to control the target Z elevation. Sometimes you may want only the horizontal XY position to be moved. Sometimes you want XY and both Z to be changed. So that is specified here. Then there are two tolerances here. One is called endpoint tolerance and the other one is nearest tolerance. Now the endpoint tolerance has higher preference over the nearest tolerance. Choosing these options on or off ensures that either endpoint or nearest or both of them are considered during snapping. So first, the endpoint tolerance distance is checked. So that is why I said the endpoint tolerance has higher preference over the nearest tolerance. First, when you are looking at any network data, it will check whether there is an endpoint within the specified distance. So in this case, we have specified 2. So within 2 units from the point, is there an endpoint? If there is one, it will snap. If there is no endpoint within 2, then it checks whether the nearest tolerance value is set and what is the value there. If it finds a nearest point within this distance, then it's going to snap. So that is the difference between endpoint and nearest tolerance. Now if you choose node as the snapping option, node to line or line to node, then you have a third option here which is called as node tolerance. So node tolerance means this is the distance from the point under consideration to either the point or the block, because blocks also are considered as point objects. Then there is a Z snap tolerance, which means change in Z more than this value will not be accepted. So if it's within this value, it will be accepted. Again, you can specify this data depending on your design data to ensure that there are no snapping of Z coordinate which would result in totally wrong Z values. These three snapping options here, snap automatically will automatically snap everything. Snap automatically and mark snapped points will leave a small marker on the screen so that you will know where the point was snapped. Mark points that would snap but do not snap them. So this will create some points in the temporary layer which will tell you later that if you apply this operation with the snap, then it will be snapped, but actually it will not snap it. So it's something like a preview. Now there's also a debug option here to create a crash analysis debug log files of entities as they are processed. Now normally you can uncheck it. You have to check it only if you are doing extremely large data sets and if you have a feeling that your program might encounter some difficulties and crash. In that case you can switch it on, and this also helps us to help you to figure out what's going wrong in your program. So for now we just leave it off. Alright, so let us start this command again and right now if you see in this data here, I have some points which are not exactly aligned with the endpoints, but they are little away. So this is for node to line snap. So which means these points I want to move it and snap exactly to the nodes. I choose the option as node to line. I chose X, Y and Z. In this case it's 2D, but doesn't matter. Now endpoint tolerance is 2. If you don't know how much is 2, just click on show, and by visually looking at the data, so let's say I will give something like this. Okay, this much, so maybe 2.1, and then if no endpoint is found within 2.1, I can either snap, or in this case I'm just going to leave it, which means I want only an endpoint snap. I don't want it to snap to any nearest point. I want it to snap only if there is a real endpoint which it can find. So snap automatically, I'm choosing this option, and then I'll say OK. Then you get the standard box for selection. So here I'm going to say scan selected objects, and I'm going to select all this and say apply. So you can see that now it's doing the snapping. So depending on your data set, it may take a few seconds to maybe a minute or so, depending if your data is big. So now if you zoom, so can you see that the points or nodes have got snapped to the line endpoints exactly. So this is because these are all points which were within 2.1 from the nearest endpoint. It has not taken any nearest point here because we chose that option off. So that's how the node to line option works. This is very useful in drawing cleanup, map digitization, GIS data preparation, topology creation and such things. Now we will look at the opposite. This is called line to node snap. So for example, in line to node, see I have a line which is ending here. This line also ends here, but my node is little away. So if I want these lines to come and touch these points, then I must use a node to line snap. The concept is exactly similar. So we just change from node to line to node. And here I am going to specify a node tolerance. So right now it's showing 1, so I will just increase it a bit, so maybe make it 2. And the rest of the options are, I've already explained, it's the same. So we'll say OK, scan selected objects, and I'm going to select all of this. Okay, so it's done it. So now you can see that all your lines have moved and joined the points. So that's why you can see all these dangle errors here, or dangling lines. So what in GIS language we call either as an undershoot or a dangle error. So here the line to node snap happened. So lines moved and joined the points, or lines moved and joined the nodes. And in the first case it was nodes which moved and joined the endpoints of the lines. So this is a very useful and powerful command, and extremely applicable in GIS data preparation jobs. So like I said, when you are doing data which has polylines, you must be careful to note whether you want to process all vertices or first and last only, because in most cases only the first and last vertices will be having an incorrect digitized connection, and those have to be snapped properly. The rest should be left as it is. But if you're doing a traverse, then it's possible that you may want to snap every point of the polyline, every vertex of the polyline. So in that case you must use the all vertices option. So use it, do some tests, and you will get a hang of it, and it's easy to use and very reliable and quite a robust command. Thank you for watching this video, and do let me know if you have any questions.